All right, so okay, so we want to take a look at some of these problems. We won't get through all of them. Let's take a look at a few of them. So problem number 5. So problem 5 says find two positive integers such that their sum is 40 and A maximize and B minimize the sum of their squares. Okay, so if you need two positive integers, you need names, so you could let A and B be greater than 0, and they're positive integers. Their sum is 40, A plus B is 40, and you want to maximize the sum of their squares. So you want to A squared plus B squared equals, I don't know, you can make it capital S for sum of squares or something like that. So once you have that information up there, yeah, see, it's not showing up as clear now. Okay. Once you have that information up there, then the next thing you need to do is to maximize this. So to maximize or minimize it, you have to find the critical values and go from there. But you're trying to maximize the sum of squares or minimize it. So it'd be best if you could get rid of one of the variables on the other side. So you use the constraint equation, which is A plus B is 40, to get rid of one of them. Let's say we use B, so we get rid of A, so that becomes 40 minus B. So you rewrite the optimization equation as 40 minus B quantity squared plus B squared equals S, and that gives you your optimization equation. You could go ahead and multiply it out, or you could leave it alone, and you could take the derivative at this point. And if you take the derivative at this point, you would get 2 times 40 minus B to the first power times the derivative of the inside would be -1, because you're taking the derivative with respect to B, plus 2B equals the derivative of S with respect to B. And then once you have that, you can go ahead and multiply it all out. So this would give me 80 minus 2B with a negative on it, which would make it -80 plus 2B plus another 2B is the derivative of S with respect to lowercase b. You can combine your B's, and so you get the derivative with respect to B is 4B minus 80. Critical values, either the derivative is not defined, it's defined everywhere, over the domain. So the second one is when does it equal 0? Well, when does that equal 0? B is 20, just 20. So if I put in 20, then I need to know, is this going to be a maximum or a minimum? So if it's a max or a min, what I'm looking for then is, I mean, I could do the analyzing the signs, but this is such an easy derivative. Just take the second derivative, and the second derivative with respect to B both times would just be 4, but 4 is positive, and since it's positive, that means that it has to be concave up everywhere. So it's concave up everywhere, which means that this has to be a minimum or a maximum if it's concave up. It's a minimum. So we have a minimum at B equal 20, and if B is 20, then A is 20, and that came from the equation where I solved for A. And then the next question was something about, can you maximize it? Well, could you maximize this?
It's always concave up, right?
It's always concave up. If it's always concave up, can you get a maximum? No, so you can't. Okay? So that's pretty much it for that one. Well, that's interesting. Okay, so the way the web work is interpreting it, if you just made it's not worded great. If you read the wording, it says 2 positive integers. If you do 2 positive integers so that their sum is 40, there is a sort of implied restriction on them that they have to be 1 to, what would the other end be? It'd have to be 39, all right? So if you consider it to be a closed interval, could you minimize it or maximize it? If you consider it to be a closed interval, you could come up with a maximum, and this is from the restrictions of the problem. Basically, that the problem says they have to be positive numbers, so greater than 0, and they have to be integers, which means the smallest one is 1. If the smallest one is the number 1, then since they add up to 40, the largest it could possibly be is 39. And that gives you a closed interval from 1 to 39. And then if you use this idea, you could find an absolute maximum over the interval. Where would the absolute max be? There are only 3 places you can find an absolute max, absolute min. Where would they be? Critical value, but we already determined that's always going to be a minimum, or endpoints. And so we need to evaluate this at the endpoints, and my guess is, of course, it's going to be larger than what this would be. If we were to take 20 and square them, we'd get 400 plus another 400, so our sum of squares would be 800, right? In this case, a squared plus b squared would give me 800. If I use the 1 and the 39, 1 squared plus 39 squared, I don't know. I don't think that's going to be a maximum. That can't be a maximum. Is it a max or a min? What's it going to be? This doesn't make any sense. What would it be? Sum of their squares. Am I reading this correctly? What is 39 squared? Oh yeah, it would be bigger. Yeah, okay, yeah, it's a lot bigger. 1,521. Okay. Yeah, 1,522. Since that is bigger than 800, then this would be the absolute maximum. But you wouldn't be able to say which one's A or which one's B, because it wouldn't matter. A could be 1 and B could be 39, or you could swap the two. Either way would work, right? So it depends on how you interpreted the problem. It does sort of have an implied closed interval over which it works, and I'm sure that's probably the question that was messing students up. They probably got this part, but it was the implied closed interval from 1 to 39 that got them. Okay. Let's take a look at 29. Okay. Or 11. 10? Was 10 the next one on the list? 10, 11, 12. Okay. So, great. All right, so this is out of 4-7 number 10, and it says, two positive numbers, x and y, such that x plus y is 58, maximize and minimize the quality. This is basically the same problem, except in this case, what would our, now in this case it says positive numbers, it doesn't say integers. So do we have a closed interval here like we did on the last one? If it just says positive numbers, I could do 0.1 plus 57.9, right? But then I could also do 0.01 plus 57.99 or whatever it is, right? But I could keep doing that. Does everybody see that? I can keep expanding to the left towards 0 and to the right towards 58 without ever needing to have a closed interval. Okay? So I don't think on this one, because they left out the word integer, I don't think you have a closed interval. There is no maximum number that this could be to add up to 58, and no minimum. All right, so maximizing and minimizing, again, same thing. This is the one you're trying to minimize. We'll just call it S again. So y minus 1 over x equals S, and that's what we're going to try to maximize or minimize. We need to get rid of either x or y. It doesn't really matter which one you get rid of. One of them's got to go. So solving for y, I get 58 minus x. So then I'm going to substitute for y. So I get, let's see, 58 minus x minus 1 over x equals s, which you could rewrite as 58 minus x to the negative 1 as your sum. And then maximizing and minimizing. Again, you need to take the derivative, you need to find the critical values. We don't have a closed endpoint this time, so I think it's going to have to be at the critical values. So the derivative with respect to x, the derivative of 58 would just give you 0. The derivative of negative x is negative 1. The derivative of negative x to the negative 1 would bring the negative to the front, so you get a plus 1 x to the negative 2, right? So this would drop to the denominator, and you could reverse the order of these two terms. So it's written a little bit more normally as 1 over x squared minus 1. So when would this not be defined? Or not defined at 0, but is 0 in the domain of the original? No, so it is not a critical value. And the next thing is, where does this equal 0? And if x can't be 0, that's where you get your 1 and negative 1. So we'll multiply both sides by x. Since we've established that x can't be 0, it's not in the domain. And that gives us 0 equals, oh, it should be x squared. Get rid of it. So that gives me 1 minus x squared. You could multiply through by negative 1 to reverse the signs. X squared minus 1, so you get 1 and negative 1 as your critical values. I might go ahead and do the second derivative just to see. So my second derivative of s with respect to x both times, the derivative of negative 1 would be 0. Bring the negative 2 to the front, so I'd get negative 2x to the negative 3, which is negative 2 over x cubed. If I plug in these two values, this is that second derivative test. If I plug in 1, I'll get a negative 2 over 1 cubed, which is definitely still a negative number, right? And because it's a negative number, that means it's concave down, which means that at 1 I must have a maximum. So I have a max at x equal 1, and if one of the numbers is 1, then the other number has to be 57. So 1 and 57 is a max. And now let's try it at negative 1. So take the second derivative with respect to x both times and plug in negative 1. What is a negative 2 divided by negative 1 cubed? The negative 1 cubed is still negative, and a double negative makes it a positive 2, which is positive, which means it's concave up, and that must mean I have a minimum at x equal negative 1, and then the other value that you add to, where did it come from? Over here, 58 minus x. So that would be what, 59? But let's go back and check our words again, because I'm pretty sure the word said positive. Two positive numbers, so what does that tell you? You can't have a negative in there, so what is that going to do? Do you have a minimum this time? You don't have a closed interval like you did when they were integers, right? Because there is no smallest and largest x and y values. But you only have a maximum. That's not positive. So you ignore it, all right, as not fitting the words of the word problem. So you only have one value. It's the maximum at 1 in 57. And you do not have a minimum. All right? Let's see. Weird. All right. Let's take a look at maybe one more. Is there one of these that's worse than another? 13? Looks like it might be.
11 is pretty bad.
11's pretty bad, yeah.
11's pretty bad?
Yeah.
All right, let's take a look at those. That was 10. Okay. Find the area of the largest rectangle that fits into the triangle in quadrant 1. Yeesh. Okay. Yeah, I know these. All right. Find the area of the largest rectangle that fits into the triangle in quadrant 1. All right, so first thing we need to do is figure out, what does this triangle look like? So the triangle's in quadrant 1, which is only here. Sides of x equals 0. When x is 0, that is another word for the y-axis, right? So one thing that does help sometimes if you're at home is you're going to find that you have to do this later on with area anyway. Get in the habit of bringing a highlighter with you. Highlight that part, right? Only quadrant 1, x equals 0. That's part of the triangle. What else is? Y equals 0. Well, where's y equals 0? That's the x-axis, but only in quadrant 1. So that's that part. And then it gives me x fifths plus y over 9 equals 1, which I'm going to take that one and put it into slope-intercept form so I can graph it. It's a line. It doesn't look like a line, but it is. All right, so I've got x over 5 plus y over 9 equals 1. And it's got to fit into that. Okay. So how can you take this equation and solve it so that you can graph the line?
Multiply by 45.
You can multiply by 45. That would at least get rid of all those nasty fractions. So I get 9x plus 5y equals 45. Now what? I'm doing my rag. Solve for y, right? You need it in mx plus b form. So move the 9x, negative 9x plus 45, and then divide by 5. Y equals negative 9 over 5x plus, if I divide 45 by 5, I get 9. All right? So over here on the graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It crosses the y-axis at 9, has negative slope, drops down 9, goes right 5. So it's going to drop down 9 and go right 1, 2, 3, 5, which means it intersects as well right there, right, at 5, 0. Check it. When x is 5, you get 45, so the y would have to be 0, so that's definitely on the line, right? So this ordered pair, 5, 0 is on it. and so is 0, 9. Oops, that's not a very good line. So now the question is, how can you fit a rectangle in there? Well, this is going to be the part that we're looking at right there. What do you think it would need to do? I mean, let's draw it in purple. It's going to have to do something like this, right? Given my inability to draw a straight line, right? Okay. Somebody give me something where I can sort of figure out what this looks like. And we're supposed to find the area of the largest rectangle. So area of the largest rectangle. A better way of saying that would be the rectangle with the largest area, which is really what they mean. What are you trying to maximize then? The area. And so the area here of that rectangle is going to be the x coordinate times the y coordinate. Let's suppose that this coordinate right there is x comma y. Then the width of the box is x and the height of the box is y, and that would make the area xy. All right? Do we have anything else that would help us to figure this out? I mean, this is our optimization equation. This is what I'm trying to optimize, area, but I have two variables, x and y. I need a constraint to get rid of one of them.
You have a y equals.
I have a y equals. Why can I use this one? To be the largest rectangle, what does it have to do? It has to touch the line. If it touches the line, that point where it touches has to be on both, which means the coordinates x, y have to also satisfy this equation. This becomes the constraint, right? So once I have that, I replace that up in here. -9/5 x plus 9. I would probably multiply it out. And then take the derivative with respect to x. You're trying to maximize, find the critical value, make sure it's a maximum, blah, blah, blah. Does that make sense? This is the difficult part. And again, just like in the related rates problems, it's the picture that gives you the information you need to do it. The picture's the key. So what other problems were really difficult, did you say? 19? 13. Oh yes, 13. Yeah, I know it is. It's the Mormon Window. I'll tell you what I'll do. I'll post that one, because that one takes a long time to do. That's called a Mormon Window, by the way. I'll post that one. And was that the only other one that was really?
There was one about gas line or something going into the ocean.
Oh, 19.
Yeah, 19.
Okay. So got one more, and then we'll start some new stuff. I will post the Mormon Window. It is a more difficult problem, so I will get that posted for you.
Are you going to collect 4/7 today?
Am I going to collect 4/7 today? I won't count that one. I'll spot you a problem. I wouldn't have counted it anyway. Yeah, sometimes you end up with more points than what was on the homework, because I know there's a problem or two in there that I didn't really expect you to get necessarily. So I usually spot you one or two problems on an assignment like that. And the Mormon Window would definitely be one I would spot you. Okay. All right. So this one says a small resort is situated on an island that lies exactly 3 miles from P. I'm going to shrink this up. A little more space to write. The nearest point to the island along a perfectly straight shoreline 10 miles down the shoreline from P is the closest source of fresh water. If it costs 1.8 times as much money to lay pipe in the water as it does on land, how far down the shoreline from P should the pipe from the island reach land in order to minimize the total construction costs? Ooh, okay. Well, I'm trying to minimize cost. So I need cost equals for sure, all right? Because that's what I'm trying to minimize. The next thing I want to do is I want to take a look and draw a picture of what the situation says. A small resort, got it, is situated on an island. Okay, well then here's my island. Exactly 3 miles, okay, from P. Where's P? The nearest point to the island along a perfectly straight shoreline. Okay, no shoreline's perfectly straight, but this one is. All right, so we have a perfectly straight shoreline. Here's my resort. And I can draw a line straight to it. What do you know about a line that goes straight to a perfectly straight line? What is the... It has to be a 90-degree angle. That's what you get from geometry. If it's at any angle other than 90 degrees, there's a shorter line you can draw, okay? So from here to here, this is 3 miles, and it has to be at a 90 degree. The 90 degree is important. All right, 10 miles down the shoreline from P, okay, so is the closest source of fresh water. So this is point P, and let's suppose we have a freshwater lake right here. This is our closest source of fresh water, right? And that is 10 miles down the shoreline. So from here to point P, that's 10 miles. If it costs 1.8 times as much money to lay pipe in the water, I gotta put that down somewhere, but it doesn't really go on my picture, it's cost. So 1.8 times in the water, as it does to lay the pipe on land, times in water as on land. How far down the shoreline from P should the pipe from the island reach land in order to minimize the total construction costs? Okay, let's talk about what they're doing now. What are your options to get a pipeline from here to here? What could you do? What's option 1? Go straight there. If I go straight there, 100% of the pipeline is underwater. Does everybody see that? But it's more expensive to run the pipeline in the water than it is to run the pipeline on land, which means this is probably going to be very expensive. So give me another option. Instead of running it straight to the lake, what else could I do? I could go straight to the land, right? And then go straight down the shoreline. Does everybody see that? I could do that. If I do this though, the one that goes strictly through the water is the shortest distance, right? The shortest distance between 2 points is a straight line. But it's the most expensive way to lay the pipe. The purple is the longest distance. I don't know if it's going to be shorter or not. Does that make sense to everybody? It might be, it might not be, right? Part of it would be under the water, part of it would be on the land, right? This part would still be 1.8 times the cost of putting it here, right? Does that make sense to everybody? All right. What's the other option? There's one more. What is it? A little bit of both. Take it part way to the land, right, at an angle, and then come across like that, right? So how are we going to figure this problem out? What do we need to do in order to figure it out? I think we've got everything on there we need. What am I looking for though? The one thing I don't have up here yet is what I'm looking for. How far down the shoreline from P should the pipe from the island reach land? They're looking for that. At what point does the pipeline reach land? Now, if I do the red line, then the point where it reaches the land is going to be 10 miles, right? Because that's the first time it hits land. If I do the purple, it goes straight to point P, so X would be 0. Does that make sense? If I do something in between, then the green, then the X is somewhere between 0 going straight to point P and 10 miles going straight to the lake. So I'm trying to find X so that my cost is a minimum. All right? Questions on that? Okay. How do we do the cost? Go off. How are you going to do the cost? How would you figure out the cost?
Would you try to find X, or would you try to find, like, would X be, because you're going to want to find the hypotenuse, right, as well?
Maybe, maybe not. I'm not trying to minimize the hypotenuse, I'm trying to minimize the cost. Let's say the cost is, let's see, what would be a good variable? I've already used C for cost. How about P per square foot, or P per foot, not square foot, but P per foot. The price on land is P per foot, all right? It's gonna cost me P dollars per foot to lay the pipeline on land, right? What would the cost of running the pipeline on land be? How far is it going to run on land, assuming the green? Now, if it turns out to be the red or the purple, I'll know because my X value will either be 0 or 10 miles. But I'm going to assume it does the green. So it goes from the island at some angle, hits the shoreline, and then travels the rest of the distance over here. From P to where it hits the shoreline, that's X, but from P to the lake is 10 miles. How long is that little section then? 10 minus X. So on land, it travels 10 minus X miles. So what's my cost on land? This many mile, well, let's make this per mile. I put it in miles, didn't I? We'll make it P per mile. 10 minus X times the price, right? Okay, now what?
Cost for in the water.
All right, I need the cost in the water. How far did it travel in the water? That would be this green, right? But I have a right triangle. This leg is X, this leg is 3 miles. Can I find the distance that it traveled under the water? What would the distance under the water be?
X squared plus 3 squared.
Square root of X squared plus 3 miles squared, which would be the square root of X squared plus 9. Okay, okay? So I need to add to my cost function the square root of x squared plus 9. Now that's just the number of miles it travels. What's the cost? If it costs p miles on land, what does it cost on water?
1.1.
P in the water would be 1.8 p per mile, right? So then I'm going to take this and I'm going to multiply by the 1.8 p, right? Now the p doesn't really matter. The p is sort of a there and gone variable. It's the same for both, right? So in this case, I don't know anything else about the price. I don't think it told us anything else, did it? No. So I could assume, for example, that p was 1, or whatever it is, or that p is some known value, right? I mean, whatever the value is it not a constant? The price per foot or mile is not going to change, right? This is the price on land, and it is 1.8 times that much in the water. The P is not a variable. P never changes. That's how much it costs to lay the pipe on land. And 1.8 times that, that's how much it costs to lay the pipe in the water. So the P is not going to affect where the critical values are because it's a constant. We don't know what it is, but it's a constant. So what I need to do now is take the derivative of the cost with respect to the only variable that I have, which is x. So you're going to take the derivative of the cost function with respect to x, considering p as an unknown constant, but fixed value. All right? So when you take the derivative of that, if you were to multiply out the cost function, you would have 10p, but the derivative of 10p, p's a constant, so it goes to 0, right? So what would the derivative of negative px be? Negative p. And then down here, the 1.8p is again a constant, so this gives me 1.8p. You have the derivative of the square root, which is 1 over 2 the square root. Then you have the derivative of what was under the square root, which is 2x. And that gives me, I'm going to turn it around so I have the minus p at the back. 1.8 doubled would be 3.6 px over 2 square root of x squared plus 9 minus p. Okay.
Can we just make p 1?
Yeah, you could. You could just make p be 1 and then just knock it out of the entire equation as well. You could do that. Is there any way to make this undefined? Given that x is an actual physical distance along the shoreline.
Can't be negative.
It can't be negative because you're squaring it, right? There's no way to get 0 in this denominator. So none of your critical values are coming from undefined derivative points, which means the only one has to be coming from the numerator equal to 0. What would make the numerator 0 given that p is constant and never changes? 0. So if x is 0, what does that give you? That is not what they have. Maybe I have to set this up backwards. But if x is 0, what would that mean?
It'd be the purple one.
It'd be the purple one. Yep. So unless I've set this up backwards. Oh, I know what I did. What did I do? What did I ignore? If this is set equal to 0, it's not going to be 0 when this is 0 because of the constant, right? I will have to swing this to the other side, so that's what I started doing wrong. P times x over 2 square root of x squared plus p. Oh, that's a 9. Should never have used p. Okay. Now what happens to the p? This is why I said, yeah, you could have set it to be 1, because what happens to it at the next step? Doesn't it cancel? You have a p on each side. I'm gonna move the radical over here to the left, so I get 2p square root of x squared plus 9 equals 3.6 px. The next thing I would do would be to divide both sides by 3.6p, and the p's cancel, which is why it doesn't matter what the price was. 2 over 3.6 is 1 over 1.8, so I get x squared plus 9 over 1.8 equals x. Now what? Let's see, I think I can take off the center part without losing anything. I want to eliminate that though. Now what? I could move the 1.8 over to join the x. That might make it a little bit easier to deal with. X squared plus 9 equals 1.8x. Square both sides. Be aware this is risky because it's not a one-to-one function. You could get a false solution. Somebody tell me what 18 squared is. I don't know. I know it's somewhere 280. Is it 324? Or somebody tell me. Is it 324? Okay. So I get 324x squared. That's going to be a 3.24 when you square both sides. Now what? You're almost done at this point. Keep going. Now what? Move the x squared and the 9 over here. So that would give me, or I guess I could leave the 9 there. This gives me, if I subtract the 1x squared, I get 2.24 x squared, and then I can take the square root of both sides, or I can divide by 2.24 and then take the square root of both sides. Whichever one you prefer to do. What do we know about x? Has to be positive. I already wrote the answer. Okay, so that gives me 3 over, and I don't think 2.24 is a perfect square, and it can't be, because 225 is a perfect square, right? So it's really, really close to 1.5, like really close to 1.5. So, but I would leave it under there, and that's got to be x. The only other thing you need to verify, since we only got one critical point, what do you need to verify? Is it a max or a min? What are you trying to do? You're laying pipeline. You're trying to minimize your cost or maximize? Minimize. So we're looking for a minimum. I would probably take the first derivative here, possibly, and maybe compute the second derivative to do that. I think that would be easier to prove that it is a minimum, right? And then whatever that comes out to be, it's pretty close to what that is.